Okay, in this presentation, I'm just going to give you a brief introduction, especially in terms of foundational ideas of research methods. Essentially a little bit about what it is and what role the methods play in international relations. Methods is really at the heart of attempts to be scientific. And even though theory is an important, a vital part of scientific inquiry, uh, the folks who are really trying to be scientific and thus positivist in their approach to international relations are often often the methodologists. And by the way, methodology just refers to how to examining data, examining information, right? So people who either do experiments or go into the field to do research or pore over historical records or look at data sets, and this is increasingly the more common thing, to look over data sets with, do statistical tests on them. All of these people are involved in empirical research. The ones who are methodologists tend to be more systematic about it than perhaps the field research, although that's not a really good distinction in some ways, because people who study methodology will tell you, oh yeah, there's methods to historical research and all these other things, but usually when people use the term, they have in mind the guys who are doing these papers where they're running statistical tests on big databases. But it's not all about that, so just keep that in mind. I want you to have kind of the broad definition and then the more common application of it. In general, though, scientific inquiry, what does this mean? And King, Cohen, and Verba produced a text on methods, and they said this. They defined scientific research as or they explain that it's designed to make descriptive or explanatory inferences based on empirical information about the world. Descriptive inferences are inferences that just say, all right, this is what's happening, right? If we boil water at a higher altitude, it will boil at a lower temperature than if we do it at sea level. That is a descriptive inference. It's more than an observation. Usually with descriptive stuff, we think in terms of observations. But then there's the explanatory. Explanatory inferences are about explaining relationships to phenomena. And water will boil at a lower temperature at a higher altitude because of the lower air pressure makes it easier for the molecules to excite and get into a gaseous state. Or what, I think that's the explanation, but you get what I'm saying. That's an explanation rather than simply saying this is descriptively what's going on, right? So we have description and explanation. Those are the big things. Theory is always about explanation. If you see explanation, there's got to be a theory involved. Okay. Empirical information about the world. This is data, right? What is data? And frequently you'll hear people talk about anecdotes, which are, examples, historical examples, and say, oh, well, that's anecdotal information, not data. Well, what's the difference? Data is any observation of the world that is done systematically. So if you look at the thermometer outside, that's a fact. It's 95 degrees. It's an observation. It's empirical, right? If, on the other hand, you look at the same thermometer at the same time of day every day and record the temperature, right? And this is doing it systematically. Same conditions every day, or even if you even did it every week, it would still be systematic, right? And that makes it data, right? Systematically observed facts are data. Now, I have shared in other contexts, I believe, this, when we talk about scientific inquiry, there's the old Will Riker thing. When we utter a sentence about reality, we do something to prove it's right. And that was what he said said to me one day. I was trying to say, what is, come, let's get down to what it is. There's so many different things that people do. What's the important thing? And the important thing is, if we say something about the world, we've got to do something to prove it's right. Now, we can't ever prove anything, and this is the thing. It's this kind of a colloquial way of putting it, because in science you never prove anything. You actually derive theoretical explanations of the world from which you get hypotheses about what you should observe in the world. Right? The theoretical explanation of how air pressure affects water boiling will give you some hypotheses, right? Hypothesis one is that if I go up to a high altitude, things will boil at a lower temperature. Hypothesis two is if I boil water in a partial vacuum, it will also boil at a lower temperature, right? And that's what hypotheses are. They are they go from the theoretical explanation to make specific predictions about what we should observe in the data, right? And then we can go test that. And this is what generally science does. It goes, you have an explanation of the world. From it, you derive a testable hypothesis. And then you go out and you conduct an experiment, collect data, or do whatever to observe, to test whether or not the theory holds water. And if the theory, if you fail to falsify the theory, you're confident. You're more confident in it. So we never actually prove anything, but at least we go out to do something, right? To test it, to throw it up against the wall, see if it sticks. That's the key thing about science. All right. Already explained, I had this slide. What's the difference between theory and methods? All right. Theory explains relationships between phenomena, usually in terms of causal relationships, right? It explains how one thing affects another, and it's usually a cause and effect thing. Doesn't always have to be, but it usually, that's what you're usually trying to get at, right? Methods empirically examines phenomena and looks for relationships between them. And like I say, in the scientific approach, it usually is looking to find relationships that are predicted by theories, which is just another way of saying testing hypotheses, right? And hopefully a more substantive and intuitive way of saying it. This is what methods is and empirical research is about. And usually it involves a systematic approach to looking at facts, or which become, when looked at systematically, become data. Right? And so empirical is always about observing the world. Theoretical is always about producing explanations of relationships. Right? Theory is idea-based, methods is facts-based. Methods almost always, however, uses theory as its starting point, because the methodologists are usually trying to test predictions made by theories. So that's how, this is the division of labor between the two. Okay, now you got two styles of research. One is quantitative, right? And this, there's a lot of this out there. And generally when people talk about methodology, when you take the research methods course, there's going to be a lot of time spent on the quantitative stuff. And this is statistics. This is looking at large data sets and running regressions and various other statistical tools on the data to discover relationships. And generally with the quantitative research, it depends on you having data. It depends on having numerical measurements of specific, well-defined, and limited variables. That is to say, variables that are, defined. And well, also, the limitations on what you look at are, theories tell you which variables to look at. We're not throwing every piece of data we have in the world in the hopper to see what comes out. We are using theories to say, all right, you need to look at these 5 or 6 things. Or maybe we're comparing 2 different theories. So one theory says, look at these things, then 3 things. The other theory says, look at these 4 things. So now we're looking at 7 things, right? That's the limitation. And like as I already said, this is where these guys will talk. We are testing hypotheses, and they will write papers that have this structure, that have a little math in them, and that use the language of, hypothesis one, hypothesis two, and then they will go and test these in their data, and this is how they end up with their conclusions. Then there's the qualitative stuff. Qualitative research is, these are the things that are more like histories, case studies, interviews with people, and this does not depend on numerical measurements. This is absolutely not worrying about whether you have data. It is generally, the qualitative stuff is trying to look at a large amount of information in context. And when I say large amount of information, it's usually a large amount of information about a particular case. In the quantitative approach, you can have an incredible amount of information, but it might be fairly limited observations on a huge number of cases. So we might have an idea about when war occurs by looking at every pair of nations over hundreds of years, and trying to understand, well, these guys, who went to war and who didn't, right? And think about that. Every year that Ecuador and Thailand don't go to war, that's an observation of no war, right? And so basically you take the number of nations, square them, right, and then multiply them by the number of years in your data set, and you have that many observations of pairs of nations either going to war or not going to war. Wow, that's a lot of data. However, it's for each observation, it's just, maybe one thing, or the names of the nations, that's kind of taken as given. But, the year, did they go to war or not in that year, right? That's quantitative stuff. Very often, lots of cases, limited information in each case. Qualitative is large amounts of information on a smaller number of cases, and the key thing is that it's information in context. You are talking about it, you're examining it. In this case, your variables tend to be unspecified. In the other case, where in quantitative research, your variables have to be understood. You have to say, look, I'm looking, if I'm trying to explain the cause of war, I need information about balance of power between these nations, right? So I need information about their capabilities, and in order to say, is war more likely or less likely when there's a balance of power? If you want to test that hypothesis or that prediction of realism, you would have you would right at the get-go, you would know, all right, this is what we're looking at. If I'm testing a realist proposition, I ignore a whole bunch of stuff and I just look at capabilities, because that's what the theory says is important. That's great if you're working within a theory, especially a more developed theory. What if you're looking at something that the theory isn't as well established, right? Your variables might not be specified, right? The theory specified just means tells you which ones are important, telling you which ones, right? So you might not have a theory telling you which ones are important ahead of time, right? Specifying the variables that you look at. Therefore, if you don't have that, you look at a lot of things, and you're kind of, and they're not going to be as defined, as narrowly defined, and because there hasn't been all this work on it. And so you're kind of sifting through a lot of information in context, and you're trying to seek out explanations, well, not explanations, you're trying to seek out empirical relationships, or maybe to understand them, empirically what was going on. That is qualitative research. Both have a role in international relations. Now, we can also talk about, besides qualitative and quantitative, we can also talk about whether a study is descriptive, relational, or causal. In descriptive research, which can be quantitative or qualitative, you are simply trying to describe what is going on, what exists, right? So when people do an opinion poll, right, they are perhaps just doing, just trying to find out what people think. How many people support Obama? How many people support Mitt Romney? Right? And we're just trying to get an understanding there, right? We're just trying to say this is what exists. In a relational study, you might be looking at the relationship between two or more variables. You might want to say, hey, does gender have an effect on voting? Right? So now I'm not just interested in how many people support Romney and how many people support Obama, right? If we go back to the election a few years ago, we say, how do men, support? How are men supporting one or the other, and how are women doing it? And we start looking at a relationship between two variables. Those variables are, one, gender, and two, support for one candidate or the other, right? And so support for candidate. So now we have a relationship, right? We also might take it a step farther and look for a particular type of relation. That's a relationship that's causality, right? We want to know whether one or more variables causes or affects other variables, right? And so we might want to look at, we could look at gender in that sense, but you'd have to, we might also want to look at effects of campaigns on voting. There's a big, and I use that as an example because there's a really important question out there. Do campaigns actually make any difference, right? Does the campaign make any difference? And just give you one example, a lot of, the Nate Silver type predictions of Obama's victory in the last election, were right before Mitt Romney had been nominated. While the primary was still going on, there were predictions that were extremely accurate at that time. And there's this question of, did this whole campaign make any difference, right? And people may try to do research to try to isolate the effects of the campaign and to establish causality. Always important to understand, relationships do not equal causality. There are a lot of relationships out there in this world that have been looked at, and there's just no reason to think they have causality. And Nate Silver, in his book *The Signal and Noise*, talks about that. There's one point, whoever, what league won the Super Bowl was related to stock prices. There was actually at one point a statistically significant relationship between those two events, and that, as we're going to find out, statistically significant means it was unlikely that it randomly occurred. However, there's no possible explanation for these two events, a Super Bowl victory by one league or the other, having an effect on the economy in the subsequent months. And in fact, that relationship no longer exists in the data, but it did for a period of time. And it was just one of these it's like a French fry that looks like Abraham Lincoln. It's unlikely, but unlikely crap happens. And this one looked like Abraham. It could have looked like George Washington. It could have looked like Mickey Mouse, but it looked like Abe Lincoln. Make a lot of French fries. One will look weird at some point. But that's the thing. Is there a causal relationship? And so causality is very difficult to establish. And usually the most important way to establish causality is through a theoretical explanation of, this is, logically this should have an effect. And if we then see the predicted empirical relationship, we're pretty clear on causality. So keep that in mind. The most, you'll hear about descriptive studies a lot. You'll hear about, and there'll be a lot of talk about causality. Generally, the descriptive and relational are the two. Well, generally, scholarly research tends to be relational, and whether or not they can establish causality is problematic. Usually, they look to the theory to do it. So, most statistical research you see out there will be trying to find some relationship between variables, especially that predicted by a theory. When we talk about variables, a variable is just something that is observed for, we have in a data set, and here we're kind of moving into the language of quantitative research. when you have a data set, you have observations. And so it might be, a country in a year, right? So we might observe United States in 1936. And then we have variables, right? So we might look at population, gross domestic product, whether or not the United States was at war in that year, right? What the party affiliation of the president was that year, who the president was that year. These are all variables, right? Because they vary. The population varies, whether or not you're at war varies, but they're all the same, right? We're looking at the same thing. Just like looking at temperature every day. If I measure the temperature at noon every day, that's a variable because it varies every day. That's what I'm interested in. And each day is an observation. Now, given that we have a bunch of variables, what we're often interested in is which one's the dependent variable and which one's the independent variable. And this is an important this is some important terminology to get under your belt. The dependent variable is usually the thing you're trying to explain, right? It is generally what you're interested in, right? And those things about the United States, whether it's at war or not, right, or whether it's at war with a particular country or not. This is something, this was the main dependent variable of realism. They tried to predict when wars were more or less likely to occur, right? It's called the dependent variable because it's thought that the value of the variable depends on some other things, right? So whether or not there's war in the realist theory, whether or not war is occurring depends on balance of power or the distribution of power, the distribution of capabilities in the system. Right? See, does that make sense? So this is why we call it the dependent variable. It's the thing you're interested in. It's the thing you're trying to explain. And by the way, it's denoted as y. And when people lay out models and use math to try to explain these things, it's always the dependent variable is always y. Then we have the independent variables. Right? Now, in theory, these are often called explanatory variables. In methods, they're the independent variables. And independent variables are things that are thought to affect the dependent variable. And they're the things that we're looking at to try to explain the dependent variable. In other words, these are the things upon which the value of the dependent variable depends. And therefore, they are independent. They just occur, right? And in my example, right, what's the independent variable? The balance of power, right? Or the distribution of capabilities, if you prefer. But that's the independent variable. So we always want to keep that in mind. And keep these in mind. And keep in mind that both theory has a dependent variable, and they have independent variables. Like I say, sometimes they'll use the term explanatory variable. It's the same thing as an independent variable. And the methods also has the same thing, right? And the dependent variable, as I always say, that's the thing you're trying to explain, right? And if you don't know what your dependent variable is, if you don't know whether you're trying, are you trying to explain war, or are you trying to explain military spending or military power, right? In realist theory, the military power is the independent variable. What they're really interested in explaining is the occurrence of war. However, it might be in your research that you are interested in balance of power or the distribution of capabilities as a thing in and of itself, right? And so you might be interested in that. That would make it your dependent variable, because the key thing is the dependent variable is picked by the researcher. It's what you're interested in. Now, in these theories, these theoretical schools, all of them share this interest in that variable. But you'll notice that some theoretic schools, realists are very interested in explaining war. Liberals are interested in explaining other aspects of international relations. They have different dependent variables. That makes sense? Okay. All right, when we talk about measuring variables, first of all, this is obviously a huge part, right? we talk about the world in terms of variables. We have observations for each event. We have observations. We have variables for each event, for each observation. So for the United States, we might have the United States observed in a year, right? And we might have GDP, population, whether or not it's at war with the country, party of the president, the amount of raw iron or steel produced in the country. All these things are variables. Now, generally, when you come from the theory, you're always going to have a kind of a meaningful thing, right? The theories don't necessarily talk about the importance of pig iron production or population or GDP. Well, maybe GDP, but in terms of things. The theories are usually talking about the world in more abstract terms. And so we hear that war, whether or not war occurs, depends on a balance of power or a balance of capabilities between two nations. And, when there's an imbalance of power, war can occur. And so the dependent variable is war, the independent variable is power, or the balance of power. All right, well, we gotta measure this. How do you do that? Well, the first thing is you mess around with the definition, right? You say, hey, I have an abstract meaning here. Can I concretize it? And I actually have been doing that a little bit with power, right? Power gets talked about by Morgenthau and by Machiavelli and all these guys, and the neorealists get to it, and they're like, well, we need to, if we're going to ever measure this thing, we need to get more concrete about what we mean by power. And that's when they start thinking, well, maybe we need to talk in terms of capabilities, right? And if we talk about capabilities, now we've kind of developed the meaning a little bit. We're still thinking in terms of ideas, but we develop the meaning, and it becomes a little more concrete. And then you say, okay, well, what capabilities are we talking about? We're talking about potential military capabilities. And so what are things that are indicators of a nation's military capability? And you might start saying, well, their military age population, the size of their economy, the size of their military, right? That might be an important one. And, their industrialization, their industrial capacity, right? So we need to measure industrial capacity as one part of their capabilities. And, well, how do you measure industrial capacity? We need something that, we can look at and measure and come up with an answer, and we'll see we're going to be I'm talking here about reliability. Well, how about the amount of iron produced, the amount of steel produced by the economy, right? Everyone produces steel, and more steel, more industrialization, right? More industrial capability, right? There's something. And so you have this process of moving from concepts and meanings, right, which is what definition's about. Moving from the abstract kind of pure meaning of the word or the concept to a more concrete definition, explaining, getting involved in what it is and what it isn't, all the way down to, well, the selection of a set of observable phenomena that can be used to measure the thing. And that's operationalization. And it's a huge part of social science research that you take, you have to take very abstract concepts, democracy, right? Liberty in some cases, and you've got to be able to measure them in the world if you're ever to test your theories based on these abstract concepts. All right. The key thing in the process of operationalization is that there's two good things we want to come out of it. we want our measures of the world, our variables, to be reliable, and we want them to be valid. Reliability refers to the precision of a measurement, and can two people code a variable? And coding a variable is, you decide, is this case a war, an intervention, or something else? Right? Do we have a war or an intervention here? Let's just say that. That choice of what to call it is coding. So can two people look at a variable and see the same thing, or can they look at a observation and code a variable in the same way? That's the key of reliability. And generally, indicators, when you pick indicators, almost by definition, an indicator is some aspect of a phenomena or a phenomenon of itself, right, that can be reliably measured. Right? So I want to measure the industrialization of a nation. Well, the tons of pig iron they create that itself is a phenomena. It is related to the overall phenomena of industrialization, and it can be reliably measured. How much pig iron is there? And there's not a lot of dispute about that, right? There's 1 million tons or 2 million tons, and certainly there aren't the judgment calls, right? There's nothing subjective in it like there is in a war or not war, or some other things like democracy or these. And so you look for an indicator that is inherently its inherent nature allows it to be reliably measured. Let me put it that way. So that, in other words, two people looking at the same thing will get the same answer. However, can you see that maybe the level of iron production doesn't really relate too well to industrialization? Is that a possibility? And now you move into validity, right? Validity refers to the accuracy of a measurement, right? Does it actually measure what you think you're going to measure? And here, for precision and accuracy, if you've ever fired a rifle, precision is when you fire the thing, are all the rounds going to the same spot, right? If you have a tight little shot group, you used to, when you were teaching people to shoot, you tried to get them to always hold the weapon in the same way, always sight down the sights the same way, and you were trying to get a shot group that was small, right? So wherever the bullets were going, they were all going the same way. And the question was, well, all right, small shot group, good, but is it actually where you're aiming? Right? And the question is, are you dead center of what you're aiming at? And that's accuracy, right? And so, and generally you adjust sights to move that shot group to where you want it. But the point here is that accuracy refers to, well, hey, is this centered on the target? Or in terms of ideas, is this actually measuring the part of the phenomena you want it to measure? And I think in the case of the pig iron or iron production, it's reliable, but is it actually measuring industrialization? If I have one nation with more iron production than the other, are they in fact more industrialized? Or are there other aspects of industrialization, right? Perhaps more qualitative, or that we need to take into account to get at, what do we mean by industrialization? A lot of times you have to go back into, well, why are we using this concept? How does it fit in the theory? What about it are we interested in that can inform how we want to further define it and then operationalize it? So generally, when you have an abstract concept, the way I think about it is, when you have an abstract concept, in the abstract, it's almost completely valid, right? Because it means what you mean. Power, balance of power, industrialization, right? Democracy. And then as you go through the process of operationalization, you're often trying to preserve the validity of the abstract concept and yet come up with a set of indicators that can be reliably measured, right? So that we can, we're trying to, and often there's this tension between keeping the validity yet coming up with something that can be coded by two different people and have them come up with the same answer, right? And that is very much at play here. And this is an important aspect of any research into data or fact, is dealing with reliability versus validity. Now, statistics. Statistics do not equal methods, right? However, you'd be excused for thinking that was the case. Statistics are just a tool. They're an analytic tool for finding relationships in data. And so we have data, and we can find out whether or not one variable is related to another one, whether the value of that variable moves in some pattern, consistently moves in a pattern associated with the other one, right? And we can have a positive or negative relationship. We can see one variable will increase when the other one increases. That's a positive relationship. A negative relationship is one variable going up when the other one's going down. We can also have a strength of relationship. How much does one go up when the other one goes up, right? And so we find these relationships in the data, right? That's what statistics, it's one thing it does. It finds the relationship, right? And your statistical tests will do it for you, right? You can use Excel. You can find averages. You can find correlation coefficients. You can do regressions and all sorts. And then Excel's good at that, but then in any social scientist worth his salt will be using some kind of statistical device, and oh my God, we got maximum likely estimates, we got logit regression, we got probit, we got all these different kinds of things you can do. Let's not get too wrapped up in those. Let's just understand that they find relationships in data. The other thing that statistics does is it tests significance, and it says, all right, here's a relationship. Right? If we look at the data, we see this relationship. Well, what are the odds that that relationship occurs as a result of randomness? Right? And that's what significance is about. And you hear about like a 95% confidence, right? And that is just saying that, well, we see this relationship between these two things, and what are the odds that this relationship could occur? If it's 5% or less, then we're 95% confident that this relationship doesn't exist as a result of randomness. Now the thing is, even with a significant relationship, you can still find stuff, right? Go back to the relationship between Super Bowl victory and the performance of the economy, right? There was a relationship that was, a positive relationship between one league winning and the economy growing at a faster rate, that less than a 5% chance it's a result of randomness. Statistically significant. Does that mean it wasn't random? And in fact, we have good reason. We're like, yeah, we think it was random, especially since as more data came in, it eventually went away, right? And never, so significance is just telling you the odds. We're 95% sure. How many 5% bad things have, how many bad things have happened to you that where you had less than a 5% chance of them happening, right? So, you expect that to occur. However, that's the standard, right? And the thing is, if you have a good theory that tells you, hey, this should be the relationship you see in the world, and it logically it holds some sense to you, you go out and you find that relationship, and there's less than a 5% chance that relationship could occur randomly. Well, now how do you feel about that theoretical explanation? You feel much better about it, don't you? We failed to falsify it, and we're still not sure. I mean, the theory could be bull, and we could see this kind of weird anomalous relationship. But this is, probably not, right? And this is frankly how science goes forward. We come up with stuff and we have a reason to think it. We come up with an idea, we do something to prove it's right, and at the end of the day, we have some reason to think we're not wrong, right? That's all science is on a lot of days. Um, so statistics is a tool for that. Oh, by the way, you'll have sampling. Very often, sampling methods are used. It's a whole area in statistics where you talk about, well, if I get a random sample from a large group, what, you know, what are the odds that what I see in the sample indicates what I would have seen if I measured the whole group, right? And so that's where we start. Uh, almost all opinion research is based on sampling and that sort of thing. And there's a established field. We kind of know the properties of these things, and it allows us to examine smaller data sets. We don't have to ask everyone their opinion about something. We can, ask. Generally, if you do it right, you can ask 1,200 people a series of questions and be able to explain a much larger population. So, up to the world, indeed. Sampling is an important part of statistics and an important tool that we use. And so the statistics ends up being a tool. And what I've just tried to explain in all this is it's not the statistics. Don't get wrapped up too much in the statistics, especially at this point. Especially, when you have these papers, you come across papers that do statistical analysis at some point. Don't explode, right? You might not understand everything they're doing. And certainly it's, in all this stuff, at some point you throw it in the computer and it gives you an answer, right? So they don't show their math in that respect. The computer does it. So there's always this point where it kind of goes into a black box and then comes out with an answer. But understand how it fits, what they're trying to do, and you're a long way towards understanding both the discipline of international relations and understanding how much weight you should give their research, and it can be a significant amount of weight, and also how much incredulity to maintain. How much. I always say being scientific is about being agnostic. You're just always just a little skeptical, right? And so how much skepticism do you maintain about the results?